Are you done bickering now?
Yes, I am. Good morning, everyone. It's 6:46, and it's Wise Guy Wednesday. Why ask why when it comes to electricity? Well, our very own wise guy, Matt Selen, joins us today. It's an experiment that's going to
spark your interest.
I hope so.
Good morning, Matt.
Good morning, Gay. Good morning, Matt. So before we get started, I got a really interesting question last week from Sherry Givens, who wanted to know about Quasar, the planet, and Pluto, the planet, or the X-planet, I suppose it was. And then it turned out that you guys answered that question the very next day with your guests on the morning show, so I don't have to say anything about it. I thought that was just great.
We aim to
Well
please.
timed, well timed.
Right. So last week we saw how we could generate static electricity, and we put a lot of charges on my daughter, for one thing, and we saw we got sparks between steel balls and other steel balls that had charges of negative signs on them. And so I want to show today how we can get charges to do a little bit of work for us, because I think this is kind of interesting. So right in front of me is another kind of machine called a WHYS generator that is used to generate static electricity. And by the way, have you noticed these static electricity machines always look kind of weird?
Yeah.
Yeah.
This is certainly a crazy looking machine, but anyways, when I crank this thing for the very same reasons that Van de Graaff generator worked last week, we get a lot of static electricity produced, and I can show you that's the case because we get sparks. And so right now we have a lot of positive charges on the top aluminum plate over here, and we have a lot of negative charges on the bottom aluminum plate. And you'll notice we have these plates separated by some insulators. I'm going to throw this ping pong ball in here, which has been painted with silver paint, and let's see what happens. See how that thing starts bouncing up and down?
That's neat.
Okay. So the reason for this is pretty easy to explain. We have a lot of charges that are positive on the top, a lot of charges that are negative on the bottom, and those charges want to get together, but of course they can't jump that whole distance between those two plates because it's too far. So what happens is when the charges are on the bottom, or the negative charges on the bottom, when the ball is at the bottom, they get stuck to the ball. And then the ball is very light, and it can fly up to the top. It leaves its negative charges on the top, it picks up some positive ones, and then it's attracted to the bottom. So it keeps getting attracted to the top, and then the bottom, and then the top, and then the bottom, and it bounces like that. And it doesn't take very many charges to have a rather large force, so that's why this thing can bounce up and down pretty rapidly like that.
That's a ping pong ball?
That's just a ping pong ball that we painted with some silver paint. And what I'm going to do in the next segment is I'm going to show you how to put a whole lot of charge on what's called a capacitor, and I'll explain what that is. And we're going to use that to explode a very fine wire. So we're going to have a big loud explosion, and we're going to have the wire basically going up in a ball of flame, which I like a lot.
Well, we all like to watch you do those things, Matt. Okay. Matt Selen from the University of Illinois. We'll check back with you a little bit later this morning. Fun with electricity.